Hello everyone. In this video, we continue with the TVM worksheet, but now focusing on annuity problems. For annuity problems, we use the same 5 primary keys of the TVM worksheet, but the definition for the variable n is changed. Now, n denotes the number of payment periods. And then the remaining 4 variables, the definition remains unchanged. IY is the nominal interest rate per year. PV is the present value or the principal. PMT is the payment amount. This is the fixed regular payment of the annuity. And FV is the future value or the maturity value. To input for PV, PMT, and FV, again, the sign is important. For cash outflow, we use a negative value. And for cash inflow, we use a positive value. We will still use the frequency worksheet to input the frequencies. PY denotes the number of annuity payments per year. And CY denotes the number of compounding periods per year. To activate the frequency worksheet, we press the second key and then PY. PY is the second function of the IY button. In addition, we need to specify the payment timing, whether the payment is made at the end or at the beginning of the payment interval. The default setting is N, corresponds to ordinary annuity, whose payments are made at the end of the payment interval. If we have annuity due problem, we need to change the payment timing to the begin mode, BGN, denoting the payments made at the beginning of the payment interval. To change the setting between end mode and the begin mode, we click the timing worksheet by pressing second and then begin, BGN. This is a second function over the PMT button. And by default, this is in end mode. To change the setting between end and begin mode, we press second and then set. Second, and then set is the second function of the enter key. And now we change to the begin mode. For begin mode, you can see the begin indicator on the top right-hand corner of the calculator. Change it back to end mode by pressing second and then set again. And we get back to the end mode. And the begin indicator disappears. And then we can quit the timing worksheet. Let's take a look at the first example. Determine the accumulated value after 5 years of deposits of $1,150 made at the end of every month and earning interest at 6.5% compounded quarterly. The value for PY. PY is the number of payments per year. The payments are made every month. So PY is 12. CY is the number of compounding period per year. The interest rate is compounded quarterly, so CY equals 4. And then N denotes the total number of payments. The annuity lasts for 5 years, and the payments are made every month. So the total number of payments is 60, 5 times 12. And then IY, the nominal rate, 6.5%. PV, there's no information from the question regarding PV. There's no initial deposit in the account. So PV is 0. PMT is the annuity payment amount. In this question, it is the deposit of $1,150 at the end of every month. So the payment amount is $1,150 because this is a deposit. You need to take out money. This is a cash outflow. So we need to have the negative sign. And then the variable FV, this is asked in the question. For annuity problem, we need to specify the payment mode, the payment timing. In this question, the deposits are made at the end of every month, so the payment mode is end. We can key this in to the calculator. Confirm the payment timing by pressing second and then BGN. So this is the end mode. Or you can confirm it that the BGN indicator is not appear in the calculator screen. Let's key in the frequencies. Second, PY to activate the frequency worksheet. PY is 12. So enter 12 and then enter for PY. Press the down arrow key and then key in CY. CY is 4. So 4, enter. Press the second button and then quit the frequency worksheet. And then clear the TVM worksheet by pressing second and then clear TVM to clear the memories if necessary. Key in N. N is 60. So 60 for N. And then IY 6.5. PV 0. PMT 1,150 with a negative sign. And then we can compute the future value FV by pressing CPT and then FV. And we get the answer. This is the accumulated value after 5 years. This is positive because you can receive this money at the end of year 5. The next example. A $20,000 loan requires payments at the end of each month for 2.5 years. If the interest rate on the loan is 9.85% compounded monthly, calculate the size of each payment. The frequency PY. The number of payments per year. The payments are made each month. So PY is 12. CY, the interest rate is compounded monthly. CY equals 12. And then N is the total number of payment periods. The annuity has a duration of 2.5 years with monthly payments. So N equals 2.5 times 12, which is 30. The nominal rate, 9.85. PV, 20,000. This is the loan. You receive the loan at the time of the borrowing. So this $20,000 is a cash inflow, and this amount denotes the present value. And PMT is the payment amount. We need to compute it. And then FV, the future value or the maturity value. You must settle the loan in 2.5 years. So the outstanding balance of the loan, which is FV, is 0 by the end of the 2.5 years period. The payment mode. The payments are made at the end of every month. So the payment mode is end. Let's solve the problem with the calculator. The frequency worksheet. PY is 12. And then CY is also 12. And then we can quit the frequency worksheet. Clear the memories of the TVM worksheet if necessary. The variable N, 30. IY, 9.85. PV, 20,000. And then FV, 0. We can compute the payment PMT. So compute CPT and then the button PMT. We get the payment amount. This is the amount we need to pay for the loan at the end of each month, a cash outflow. So from the calculator, we have a negative value. So the payment is $754.83. Let's take a look at the next example. Calculate the present value of payments of $5,000 made at the beginning of each year for 7 years at an interest rate of 4.8% compounded monthly. Let's take a look at the variable. PY is 1. The payments are made at the beginning of each year. CY is 12. The interest rate is compounded monthly. And then N is 7, the total number of payments period. The annuity lasts for 7 years and the payments are made every year. IY, 4.8. PV is the variable we need to compute. The question asks about the present value. The payment amount, negative 5,000, because this is payment, cash outflow. And then for FV, no information is given in this example, so we assume that FV equals 0. And then the payment mode, begin mode. The payments are made at the beginning. All right, so we need to swap from the default setting, the end mode to begin mode by pressing second and then begin. Begin is the second function of the PMT button. To change the setting by pressing second and then set. Second and then set. We can see the BGN indicator on the screen. This is done. We can quit this worksheet by pressing second and quit. Make sure the BGN indicator is on, and then key in the frequency. Activate the frequency worksheet. PY is 1. And then CY is 12. Quit the frequency worksheet. And then key in 7 for N. IY 4.8. PMT negative 5,000. And then FV is 0. And then we can compute the variable PV. This is the present value of the annuity, $30,454.10. The next example. Anna is planning for her retirement. She wants her retirement account to provide her with $2,500 at the end of every month for 15 years after she retires. If the retirement annuity earns 10% compounded annually, how much money does she need to have in the account when she retires? Let's fill out the variables. PY. The payments are made at the end of every month. PY is 12. CY, the interest rate is compounded annually, so CY is 1. And the total number of payments periods, 15 years, the payments are made every month. So N is 15 times 12, which is 180. IY, 10%. And then for PV, in the question, we need to compute it. The question asks about the amount of money she needs to have in the account when she retires. And then with this amount, she can get $2,500 at the end of every month for 15 years. So this is the quantity asked in the question, the PV. PMT, the $2,500, she received it. This is cash inflow, a positive value. And FV, the account balance after 15 years, it should be 0. The payment mode, end mode. The payment are received at the end of every month. Input these variables into the calculator. We need to change from the begin mode to end mode. We used the begin mode in the previous example, so now we need to change it by pressing second and then BGN. Press second and then set to swap back to end mode, and then we can quit the timing worksheet. The frequency worksheet, PY. PY is 12. And then CY is 1. 180 for N. IY is 10. And then PMT is 2,500. 0 for FV. Compute the present value, CPT, and then PV. This is the amount of money she needs to have before she retires in order to get $2,500 at the end of every month for 15 years. The value from the calculator is a negative value because she needs to prepare this amount of money in the bank account. So this is a cash outflow. Let's take a look at the next example. Currently, you have $8,500 in the account. How much money must be deposited at the beginning of every quarter for 3 years to accumulate up to $30,000? The interest rate is 2.25% compounded semi-annually. PY is 4. The deposits are made every quarter. CY, the interest rate compounded semi-annually. So CY is 2. N is 12. Quarterly payment for 3 years. 3 times 4, 12. IY, 2.25. PV, this is the amount of money already in the account. So it is the same as you need to take out this amount of money and make the deposit at time 0. So this is a cash outflow. PV equals negative 8,500. And then PMT is the amount of the deposit. We need to compute this variable. FV is the future value or the maturity value. Accumulate to 30,000. So FV is 30,000. The payment timing, begin mode. The deposit are made at the beginning of every quarter. So change the timing by pressing second and then begin. Change the setting from end to begin mode by pressing second and then set. And then quit the timing worksheet. Make sure the BGN indicator is on. Enter the frequencies. PY is 4. And then CY equals 2. Enter N, the value is 12. And then IY is 2.25. Negative 8,500 for the variable PV. And then 30,000 for FV. And then we can compute the payment amount, the amount of the deposit. So you need to take out the money to make the deposit. So this is a negative value in the calculator. So here, the amount of the deposit is $1,679.96. That's it for today's video. Thank you for watching and see you in the next video.